All right, so we have a situation with a traffic light hanging from two separate cables, and we were two different angles, 15 degrees here, 51 degrees here, and we have force 1 in cable 1 and force 2 in cable 2. Well, the easy way to look at this is this point of equilibrium where this thing is hanging from has to be equally pulled to the left as it is to the right, and these two up forces from those two vectors are equal to mg for the hanging 35 kilogram mass of the light. So 35 kilograms times 9.8 is 343 newtons hanging down. So that's the mass or the weight of the light. And my two equations are basically F1 times cosine theta 1 is equal to F2 times cosine theta 2. So I have this, F2 cosine 51 is equal to F1 cosine of 15. F1 cosine of 15 is this, F2 cosine of 51 is this. So this equals this, right? So that means horizontally speaking, left equals right. And vertically speaking, F1 times sine of 15, which is up, plus F2 sine of 51, up. Those two ups equal 343, which is mg down. Okay, now I'm going to take these two equations with two unknowns and rearrange. So F2 is equal to F1 times cosine 15 divided by cosine 51. So divide both sides by cosine 51. That puts F2 equals that, and then cosine of 15 over cosine 51 is 1.535. So now wherever I have F2, I can put in F1 times 1.535. So I'll do that here. F1 times sine of 15, which by the way is 0.2588, plus F1, instead of F2, we're going to put in F1 times 1.535 times sine of 51. Well, sine of 51 is 0.777. So that's that, and that's equal to 343. So now F1 times 0.2588 plus F1 times this, which is 1.1926 equals 343. And then we divide both sides by combination of these two, add these together. So F1 times 1.4514 equals 343. And then we divide both sides by 1.4514, and we get F1 is 236.3. Now, substituting that back into our original equation, which says F2 is equal to F1 times 1.535. So F1 is 236.3 times 1.535, where F2 is 362.8.